Hello friend. So in this particular video, I'm going to talk about or I'm going to explain you the particular question. Like I've already discussed one type of problem related to this type of concept. That is, in a given array, suppose all the elements are repeated twice. I repeat, all the elements are repeated twice, and you have to find one particular element that is not repeated. That was the question that I've already uploaded in my DSA problems playlist. So this is a question basically which actually not takes all the other elements repeated twice, but it actually takes elements as equal to k times, or it takes the elements, for example, three times. Like I in this video will be explaining you three times. Along with that, I will also give you the idea of k times. So this is our array, and let me take one more. So how I'm going to explain you. This is your element 4, this is your element 4, this is your 8, this, and this is your 4. So you observe that in this particular vector or array, whatever you take, this is of size 7. What is this? This is of size 7. And we have to find the particular element. This is not repeated three times. So you find that 8 in this particular array or vector is not repeated three times. So how we have to find this particular element? So what we are going to do, we will simply create a count array. What we will be creating? We will be creating here a count array. And what count array will be doing? I'm just simply telling you. Count array will simply actually try to take out, it will simply try to take out the set bit. Like it will count at every index, like each and every value. See, like for each and every value inside this array or this particular vector is of integer type. So the number of bits that can be in integer, it are what? Simple and simple are simply the number of bits inside that are number of inside the bits are like, see what, how many bits inside this particular integer array. It is simply lies between 1 to 32. So this range will be from 1 to 32. So we have to count here at every particular index. Like this will range from 0 to 32. It will simply range from which index? It will range from 0 to 32. So what we have to count? We have to count at each and every index of this count array the number of bits that are coming. The number of bits, and we will simply be counting here the number of set bits which are coming. What? The number of set bits which are coming. When we are counting the number of bits at each and every particular index of an array, so we will be counting for each element. This we will be doing for each element of the this particular array, integer array. Okay. Just you simply in this question, like what I'm counting, like at each and every index of this particular array. This array is of this array is also of an integer type. So this will simply also go to what? This will be counting from 0 to 32, isn't it or not? So what we are going to do here is that for each and every element given in the vector or array, whatever we are using as an input is data structure, for each and every element of that, we will be counting like this particular number is made up of some bits in binary form. So we will be counting like for each and every index here when they are placed. And each and every particular number, integer number can be arranged from 1 to 32 is the range for int. So for each and every value, and at each and every index of the count array, we will be counting the number of bits. Like, let me explain you. Suppose this is your 0th index of the count array. This is 1. This is 2. Okay, I hope this is clear to you all. Now, the first element is 4. So, 4, how you write? How you write 4 actually? You write simply 4 like this. 1, sorry. 4 you write like this. 4 you write like 0, 1, 0, 0. So now at 0 you are having 0. At 1 you are having simply what? And if you express Like here, if you express simply, or even you can go for 4-bit also. So you find at 0, it is 0. At again. So what you find here simply, let me tell you. If you are going in 4-bit format here, if you are going in 4-bit format, so you are now what I said, that for each and every value inside the understand this. For each and every value inside this given vector, what we will be doing? This particular is an of integer value. So this will range from 0, 1 to 32 range. And this is composed of bits. So like what we are going to do? We will simply be counting the number of bits that are coming of all these numbers at a particular index inside this. And which type of bits we are counting? We are counting set bits. So this is common. This count array will be common for all the elements of the vector. And for each and every vector, there will be number of bits will lie from 1 to 32 because they are for of integer type. So what we are doing? If you write of 4, then at the 0th place, if I represent, it is 0. At one place, it is 0. At second place, it is somewhat 1. So I make this 1. Okay. And then this is also 0, the third index. Now, if I go for 4 again, then all these will remain 0. This will become like simply, this will become again 1. Now 8 comes. So 8 is what? If you write here 8, I am telling you, 8 in binary in 4-bit format is written like this: 1, 0, 0. So you find that now at third index, this became 1. And then again your 1 came. Now 1 anywhere, it is written like this simply: 0, 0, 0, 1. So you found at that 0th index, it has become 1. Initially, it was 0. So at 0th index, it has become now 1 because we are counting the number of set bits. Remember, for another one, it will become 1. So this has become 2. And now, how the next one will also make this as 3. This has become 3 at 0th index, because at 0th index of an count array, which is actually the size is for an integer type, we are actually taking the number of bits that are in integer. What is the range of the integer? It can take from 1 to 32 bits. Simple. So we are creating a count array which is of size that is int can take. So these values of vector element are simply of which type? They are of int type. So and these vector elements can be expressed in the form of bits. So like the particular bit that is coming, like this can be, the position will be like 0, 1, 2 and all. So you can simply express it. And at whichever index of a particular number, that is vector element, it is coming the set bit, we are simply putting it into this array of simple is this kind. This is running from 0 to 3. Now, I just put 3 once will make, once will always come, the set bit will come on the 0th index. Then comes 4 again. So 4 was what? If I just write 4, so 4 was what? 4 was simply coming on this index. So this has become like this. Now, if you just say, now, suppose the number of bits that were there in the array that were repeating 3 times. So if you write wherever the number is coming 3n, so if you just simply divide them by 3, that is the time the number of elements that are repeating in the array. So if you divide them, the remainder will come 0 for the elements which are multiple of 3, or they will come as 3n plus 1, because we are dealing in binary. Simple. Those will come either 3 and that is the remainder will be 0, or they will come 3n plus 1. So if you go on doing this, what you observe here, at index 3, if you divide it, if you divide the value by 3, this is coming 1. So obviously it is like this is 1. So you will store it simply. And then at this particular index, it is 3. So it has become 0. As this particular index, it was already 0. And at this particular index, it has become 3. So this has become 0. So if you observe here, if you are dividing the number by 3, you got this particular place as 1, this particular place as 0, this particular place as 0. So what you observe here, that is equal to 8. Now, how will you take out? Using the common technique of converting a binary number to decimal, as simple as that. Now, again, I'm explaining you what I have done. before I'm going to the code. So what I have done here is that I have taken a vector, and inside a vector, it's an integer vector. The data type of the vector is an integer, and inside a vector, the elements will occupy that is from 1 to 32 bits. As simple as that. Each element can have maximum of 1 to 32 bits. So of that particular size of I have created a count array that is of 1 to 32 bits. I've taken a count array, and inside this, at every index, like from 0 to 32 of the array, what the size is 32, but indexing will start of a count array from 0 to 32. So at every index of the count array we will be finding the number of set bits of each element. At every index, remember, repeat, I am just repeating this line, this is an important one. At every index of the count array, I will be counting the number of set bits of each and every element of the vector, of the given vector, that is your this one, which has all the elements. And after doing this, because the number each and every element was being repeated 3 times, so I will do what? At each and every index of the count array, I will try to find out, I will try to divide it by that particular factor, and you will observe if the number was multiple of 3, then it will simply become remainder will be 0. And if it was not multiple of 3, then it will become 1. Now, remainder can be 2 as well, but the reason is that you are dealing in binary, so it will always come as well. So, this is the case. Now I will straight away move to code, and code is like this. You will first, I have taken here an integer value because I'm returning the result, that is a particular number which is not being repeated, and I've taken a vector. So vector is always called by reference, and then I have called computed the size of the vector, and then using the, this is what this I have taken here unsigned int, but you can simply take int as well. It won't like affect you. So you can take int, and you can take int here as well. It won't affect. Unsigned will only give you the data type. So here I have taken like this, and I will be writing here int. So that is that. And then I have taken a size. What this will do? 1 byte is equal to 8 bits, and size of int is simply, you all know. So this will make the size count array of size 32, because we want to calculate each element number of it. So each element is of integer size. So we have to obviously take an array of size 32. So this we have created an array. Now this function, what does memset do? So what does memset do? Memset basically, remember simply, this is a syntax where count is an array, 0 is the starting index, or 0 is the value which you have to set. And size of count is actually 32 here. So from 0 to 31, memset will do what? From 0 to 31, it will simply set initially all the values 0. So I'm writing here memset, memset initializes, initializes all the values inside the count array to 0. This is the case. It will initialize all the values to 0. Now, since I am using vector, so I have to create an iterator. And how it will be created, I have already taught you in STL tutorial, so you can just go and check it. And then I've created a variable to finally return the result. And I will have to run this loop from I equal to 0 less than the size of the count array, because we have to go for count array inside particular index. Like count inside for each and every index of the count array, we have to actually calculate the number of set bits. Remember this, for each and every index of the count array, we have to actually count the number of set bits present at that particular index of the count array for all the numbers in the given vector. So this will come an outer loop, and then this is simple. I took an iterator. Also, iterator will run from v dot begin to v dot end, and this will increment by 1. And this is simply the value of assessing the iterator, because iterator it points out to an address. It is a pointer basically. So you have to use like this to take out the value. And using the bitwise operator, now I have told you again and again that whenever we have to deal with set bits, we have to simply do what? We have to simply and using the bitwise, and we have to take this is your mask to calculate. And every time we have incremented, whenever we have found the set bit, we have incremented the count type, that particular index value by one. And then what we have done? See this. We have got the value as like this we would have got the value 2 3 4 something kind of that. And what we have value have got up till now in this count, let me show you. We have got this value in count, like this value 1 3 0, this will be 0 and this will be 0 because of mem set. So the value that we have got up till now is 1, this is 1, this is 3, and this is also 3. So we have got something as known as 1303. So now you will find that you will have, because I am returning the result through the variable rest. So I've done what? Rest plus is equal to count I mod 3. Now this will do what? If the number is a multiple of 3, it will simply do it 0. And it or it is, if it is not a multiple of 3, and since we are dealing in binary, so the remainder will be 1. So it will be multiplying it by this. Now this does what? Let me tell you. This does simply, I'm just writing here, 1 left shift I equal to 2 to the power n. Now, this is the method of converting. Now, if you do this, we are doing it? We are simply converting a binary number to what? We are simply converting a binary number to decimal. And finally, we are returning the result. And then we are simply doing here, let me do, we forgot to like do this. Semicolon was missing. And inside that, just created an object of the class and then just called it. So this is the particular index. Now remember, memset does what? Initially, because you initially all the count, all the values of the count array that you have created of the size of integer data type. Remember this, of the size of integer data type, they all values will be of 0. You have set them, and as soon as you operate, and as soon as you find the set bit at that particular index, like if you have to calculate for the index 0 of the count array, then you will take all the values, like all the elements, you will take one by one, and you will check that if this 4, if the first 4 has got its set bit at 0, then you will increment it. You will do like this simply, and you will do this till the end. And then you will simply return it. And then you have to do what? Then you have to simply do this, like you have to pass a vector, and finally you have to get the result. So let us see what we have done. And we should put this like I have to do this. Um, I will simply take this and I will write it like this. So hopefully this is good. And now I will be running the loop, or like I will be running the program, not the loop. So I hope this is clear. And I will be running it. So let's see what we will be getting. Required number 8. Now 8 was the number in the given array that was vector that was not being repeated. So like this. And if I just simply tell you what will be the time complexity. So what will be the time complexity? The time complexity will simply be O of 1. You are iterating till n, or not, sorry, it will not be O of 1. Your time complexity would be your time complexity would be big O of n. Now, why it will be big O of n, you just simply note. Whenever we are doing a iteration, we are simply running it from 0 to n. That is the size of the vector, or the integer. Like count array we have created, so we are simply running it from 0 to n. So your time complexity for this particular program will be, your time complexity will be equal to big O of n. And space complexity, you are thinking that we are not creating a separate variable here, like we are not creating a separate variable. So the space complexity and the auxiliary space, or the auxiliary space, will simply be a constant one, that is big O of 1. So your space complexity would become big O of 1, and your time complexity would become big O of n. And just to explain you once again, what will we doing? To explain you once again what we are doing here, we are actually creating a count array of the integer size, that is the number of bits that integer can take, that is 32. And how we have taken size of int is of 4, and into 8, you always do what? 8 into 4, that will become size 32. So we have created an integer array of size 32, and memset initializes all the values of the given array to 0 and whatever value that you want to pass. And then what we have done, we have created a count array in which what we will be doing, we will be simply doing it like we will be taking each and every element of the given vector, and in using the bitwise and we will be trying to find that at particular index of the given count array, whether or not that set bit is there or not. We will simply be counting. And finally, we will just be simply returning the value by dividing it by k or 3. Now, I just told you in the starting of this video that if I do it by k, what will happen? So with this vector, you will pass a parameter int k, and here you will pass the k value, like how many times numbers are being repeated. So this you will do simply, and here instead of 3, you will divide it by k. As simple as that. This is the logic, and time complexity and space complexity will still remain the same. So basically, here you have to do what? You have to create a count array, and at each and every index of that count array, you have to simply do what? You have to simply check for each and every element of the given vector using the bitwise and if you find the set bit, you just increment the value. So this was all about this particular question. Hope you all understood. Thanks for watching, and do like, share, and subscribe. Thanks everyone for watching.